Welcome to the Enterprise Mobility Roundup podcast, brought to you by BlueFletch. We discuss technology topics related to Android and workforce devices and how they intersect with business and mobility.
Hello and welcome to another episode of the Enterprise Mobility Roundup podcast. Today I'm joined by Patrick McGlynn, and we will be discussing the state of indoor locationing with specifically with Android devices in the enterprise. We're going to touch on a few use cases, talk through some of the background science behind how it actually works, and we'll be doing some deep dive into actual technologies for locationing. This is a sort of a precursor to an upcoming webinar that we'll be doing where we deep dive into this topic and actually do some on-device demos and show what the technology actually looks like as you're using it. So Patrick, thanks for joining me today. I guess to get us started, can you cover or talk a bit about some of the use cases we're starting to see more of, or areas where indoor locationing is creating value for folks out in the world?
Yeah, sure, absolutely. The first is around contextually aware applications, and this is really nothing new. Siri is doing this for you. If you ask what the weather is outside, it knows your location and is going to provide you that localized weather. But in the enterprise, we're starting to see more and more companies look into being able to provide tasks and recommendations based on your area within a store. So say I am working at a retailer and I'm looking at a task list. That could be a dynamic list of actions for me to take based on my location within that store. And, letting the app make those recommendations for you versus having to understand where you are, what's the nearest action item for you to take.
Got it. Similar to what's a close restaurant to me?
Yeah.
On the Google, instead of that, what's a product location that I need to go restock? Okay, that makes sense. Oh, what else?
The other one we see is around product location. So understanding where product is within a store. Click and collect is a big one that a lot of retailers are adopting if they haven't already, with just the digitization of retail and being able to understand where that product is and know how to efficiently go pick that product based on where you are in the store and the most efficient route for you to take to fulfill that order. That's ability you can start including in your app to understand where that user is and where they need to go.
Got it. And click and collect, for those of us who are in the America, that is also called BOPUS in the US, buy online, pick up in store. I feel like click and collect is definitely European or APAC. It's more common there, right?
Mm-hmm. True.
Yeah. What else? What other use cases have you seen?
Similarly with, product location is wayfinding or pathfinding. So understanding the optimal route to take within a store. And this might not be applicable to some of your smaller retailers, but Brad, you and I have been inside those 1,000,000 square foot warehouses, and you want to know where something is and how to get there instead of trying to go down these endless aisles and racks and bays. Knowing which turn to take, where you need to be down to the aisle or bay level is pretty cool and good application of that indoor location.
Yeah, I find this is particularly useful in warehouses where you have the new guy, and warehouses do have a lot of churn in their labor workforce. So the fact that you have somebody who may be new and doesn't actually know where bay 22 aisle 43 is definitely giving them that visibility is pretty important. And speaking of employees, what are the number 4 was one of the things you called out around the employee location. Can you talk more about that?
Yeah. So knowing where that employee is a big benefit, especially when it comes to safety and safety concerns. Just a quick thing I saw today in the news, actually, AT&T is starting to roll out what they're calling locate before route when calling 911. So they're going to locate you based on, the GPS in your phone and route you to the proper authorities or responder for that. And they claim that's going to be within a 50-meter radius of accurate location versus previously when you call 911, it's based on cell towers and it's going to get you within, they say, roughly a 10-mile radius. So thinking of that and how you can apply that into, how companies can apply that is with safety concerns. If there is an issue, if someone is injured or has a problem, and calls for help, knowing who's near that person, who can respond, track, what happened or what might have gone wrong is just a really great thing for employee safety and making sure that, they can be easily located by other employees if there is a problem.
Yeah, that use case is I've definitely called 911 when I saw an accident once, and they routed me to a different county, and they what- gave me like, write this phone number down, call this sheriff's department. And said, no, it's yeah, I felt bad because I'm trying to help a bad situation, and then they just didn't have the technology available for them.
Right. And you're on hold.
Yeah, yeah, no, it was definitely a dicey situation. I was not me in the accident, but I was trying to do my best to help out.
Hmm.
Number five you had was device location. So
Yeah.
tell me more about devices and I guess this is specifically around device loss.
Yeah, exactly. We've heard a lot of companies that are struggling with high volumes of device loss and turnover. And, these equipment is not inexpensive, and they want to know where those devices are and make sure they stay inside the four walls where they're supposed to be. So understanding where that device is at all times, understanding if devices are where they're not supposed to be. So if that's in a different facility because it's been cycled, or if it's, been taken off site and is still online and active, being able to drill down and find that device. And I know that's something that we've started adding into our tools as well, as having that map view, because people are so familiar with it, but being able to see the exact location of a device really helps just to keep those devices secure and where they're supposed to be.
Yeah, I know we've seen a lot of that, especially with delivery drivers, where a device is assigned to store 101, and then the device somehow magically ends up at store 105 because the driver doesn't care. At the end of his shift, he's like, "I'll just put it back wherever."
Mm.
Number six you had, which is probably for a lot of folks the most important one, but the customer interaction. So location being used for customer interaction. What are the key use
Yeah.
cases you see around that?
Customer assistance. So, hey, I'm a customer and I need help. Can I page the nearest associate to come help me? Awesome use of locationing and technology to, instead of having to alarm the whole company or staff that there's customer needing assistance, you can really direct that to the right person in the right context. Also on the customer side is just, being able to find products faster. So Home Depot application, being able to go locate that bolt that you're looking for and have no idea where it is, being able to route to that, or at least some type of wayfinding is, just a way to make that shopping experience easier for the user. And then also on the store operation side, understanding how customers flow through your store, how they move through your facilities, seeing where, there might be potentials for end caps for, high volume or high visibility areas. Really understanding that analytics can start helping those merchandising teams get the most value out of their product placement.
Yeah, and I know that first one with finding product for customers is a big one. I know we did a research project with a big retailer, and they did physical, queries of customers, and they found that the about 15% of the customers were unable to find what they were looking for in the store. And I want to say it was upward of 60% of the stores had that product. It's just customers weren't able to find it. So they definitely, there's a lot of money to be made by improving the customer experience and helping them find things better. But I
Yeah,
guess on the flip side, are there any concerns around privacy? Like I'm always hesitant when I get a pop up from an app saying, "Hey, this app wants to track your location." Like, what are the concerns around that?
yeah, absolutely. And props to Android and Apple and all the other companies for taking, steps towards making our lives more private digitally, including our location and our activity, and really requiring us to consent to that type of data. But That does make it a little bit more difficult for some of these use cases we've talked about. If the consumer chooses to opt out of sharing their location, you're not going to be able to tell them how to get from point A to point B efficiently or route them to the nearest associate. So, again, it's protecting the consumer and their privacy. But there are some other tools. I know some of the new access points that we'll get into in a minute are able to do that and do it in a randomized way, or they're gonna mask users' personal information or device information if the operating system isn't doing that. So there are some considerations. It's not just a free for all of data out there, but yeah, it just something to consider there.
Yeah, no, it's definitely it's on a lot of our minds. Nobody wants to be creeped out by their app listening to them or tracking them when it's not supposed to be. Before we hop into actually talking about some of the technologies, I wanted to spend 2 or 3 minutes to just talk about some of the fundamentals of or the what I call the science behind how this stuff actually works. And we'll call it the two key terms that sometimes get confused, and then we'll talk a bit about some of the other technologies that are out there for locationing before we hop into Wi-Fi location. But the first concept we had is it's called triangulation. And as you can imagine, it's a triangle. It's taking 3 points in space. So point where I'm sitting, and then two known locations, and measuring the angles between them to figure out where I am in space. And this is useful and the example I always think of is I've done a lot of sailing, and one of the things you do in Boy Scouts is you take a compass measurement between 2 known points on a map, and then you draw a line with those angles based on the compass to where you are. And that actually gives you your location on a map. And that's called triangulation. Go ahead.
Well, Brett, I think it actually gives you your distances. It can't give you an exact location, right?
The intersection of the two lines.
Yeah, but if you mirror that, you could be on either side of.
Yep.
Yeah. So it is good for distancing and decent for location, but it does give you 2 potential points, I believe.
Yep. Yeah, and then you use a third point for that. It actually will give you that. But normally when you're sailing, whether you're on the water side or the land side. So it's sort of intuit it that way. Definitely, if I was on the land side, I'd be at that bar over there.
So the green part is the water on the map, right?
Oh gosh. Note to self: Patrick's not driving the sailboat. And the concept number 2, which is actually the underpinning of most of the technologies that we're going to be talking about, not all of them, but it's called trilateration. And trilateration actually uses known distances between multiple points. And the easiest way to explain this is if I know 3 known points and I know my distance to those points, if I draw circles, I'm the intersection of all 3 of those circles. And it takes 3, and there's certain systems. So GPS is a really good example of this. GPS typically requires more than 3 points, because you also get elevation and you also have time synchronization with GPS, but it's using the round trip time between your GPS receiver and the satellites to actually compute your distance to that satellite. And then it uses that and then builds that series of circles to tell you your latitude, longitude, and also will give you your elevation based on that, it's cool. And then you can also get advanced things. And then one of the caveats with GPS that I see, there's actually in Android, if you read the documentation, Android actually supports the term they use is GNSS, which is Global Navigation Satellite Systems. GPS was a set of satellites that the US initially put up to support fine-grained locationing, and then a number of other countries, because they didn't want to rely on the US, put their own satellites into space. So if you look at, I think there's 5 common ones. GPS is US, GLO is Russia, BDS is China, QZSS is Japan, and GNSS is EU. And then I believe India has also put up satellites recently, but it's Android doesn't support those yet. So Android is actually looking, based on where you are in the world, is looking for those satellites and can give you a accurate location sub 2 meters based on, if you're outside, if it sees satellites, it can actually pick those up, which is pretty cool. But I guess, Patrick, I know one of the things you discussed was just some of the pros and cons of GPS. So maybe you can tell me a bit more about those.
Yeah. I think the pros with GPS, first of all, it's great technology and it's free for everyone to use. So right there, you're going to get high adoption, and that's why it is really the core of your locationing on your current smartphones for, when you're doing Google Maps and trying to drive up the highway on a road trip. It's all going to be based on that data. And there's no infrastructure that you need to have or install in your facilities to support that. However, one of the big drawbacks is that GPS signal or GNSS signal can be severely impacted by being indoors. So roof structures, concrete, steel barriers, it's all going to make that GPS data much less accurate. And if you've ever opened up, a map view while you're inside a mall, at first it's not going to have a very good accurate location. It's going to have a pretty big circle radius for you. Of course, there's additional technologies that can fine grain that location for you, but that's one of the biggest drawbacks, is that it just really doesn't work well indoors. And the second one you called out that I wasn't really aware of, Brett, was the power consumption. So it's a pretty resource heavy call to use the GPS radios to make those calls all the time. And there's a lot of developer blogs and guidelines around how often you should pull location, how accurate your location needs to be. And the goal there is just, minimize the strain on the device and the battery and the processor to do all that work.
Yeah, we had a client come to us with, I call it rescue project, but they were like, yeah, this app, we had somebody build it. It's not working right. The device ends up dying after 40 minutes. And we were like, this doesn't sound right. So we opened it up, looked at it, and it was the developer who created it was doing a GPS call, I want to say every like 4 or 5 seconds. And it was just cycling that and was just draining the battery. So it was definitely not well designed. This was before some of the newer technologies that Android and Google and Apple started adding into their operating systems. But on the newer devices, there is a location service within Android that you make a call to that, and the device itself actually determines the optimal way to figure out location. So it doesn't allow you to force that GPS call. If it can get better location from the cell phone towers or from Wi-Fi locationing or some other location, it'll use that. It'll use whatever the lowest power option is to give you the most accuracy, which is definitely a good advantage now. And just, I guess, just transitioning to talking more about indoor location, there's a lot of technologies. And Patrick, I know you did a review 4 or 5 years ago. I've done a lot of work with different tech over the last couple of years on finding the location of a device inside of a facility. But can you talk about some of the ones aside from Wi-Fi that have not necessarily panned out that we've looked at or that you've looked at?
Yeah, sure. I was actually reviewing that blog post as well that I wrote back in 2015 about indoor locationing. And it's interesting to see all the changes that have occurred, things that weren't even on the radar back then, as well as technology that really is no longer relevant. And I think one of the first ones that stands out is beacons. I remember everyone, 6 years ago was super excited about beacons and using Bluetooth low energy to have indoor location and context. That was a pretty common one. And I'm sure there's still some companies out there doing that today. And I know some of the access points manufacturers have included that within their APs as well to just, limit the amount of infrastructure that you got to install. But those beacons were oftentimes little looking tile sticker looking things that battery powered, and you could just stick really anywhere. And going back to the trilateration, that was the technology behind that, is understand where you are and understand where known points are, and you can therefore determine your location. So again, that was a cool technology, but I think people realized the pain of sticking beacons everywhere, changing out their batteries every couple of years. It starts to become a kind of a big overhead project to support.
A lot of management there.
A lot of management.
Imagine 20,000 tiny things of batteries that may get lost if the battery dies.
Yep. Another one was lighting. It's actually technology we experimented with. So lights can't, excuse me, visible light communication. So we worked with a company to test out some of their hardware, and the lights actually transmitted a certain frequency that could be picked up by your front-facing camera on your device. So my device would know I was under this, this lamp right now, and that lamp would be overlaid onto a map or XY coordinates. And so my device would know I was within this spot. And kind of cool technology, but again, relied on access to a front-facing camera, which, back to that privacy thing, most people don't want to have a front-facing camera watching you all the time while you're shopping. Two, that's also resource hungry to do that. And just third, a lot of infrastructure required to change out your whole lighting system. And in a large facilities, that's quite an undertaking.
Got it. What about sound? I think Zebra actually had this for a while. This is a similar technology where they had, I guess, APs were emitting a sound that was not perceptible to humans, and the devices are picking them up to figure out where they were in space.
Yeah.
Same concept.
Same concept.
It's definitely having to install infrastructure. Additional infrastructure is definitely prohibitive for most companies if they have to figure out some sort of location thing. And then
there was one other technology, just quickly, because it's kind of interesting to me, at least. There was a few companies experimenting with leveraging the magnometer in your device. So understanding where there are magnetic disturbances and using that to more or less create a thumbprint of your facility. So you would walk the facility, the device would pick up any electrical or magnetic disturbances like steel beams or electric wire embedded in your walls, that sort of thing. And it would start to build a thumbprint of your area so that when the next user came and that same disturbances were detected, you could try to determine where they were. And so the thought was, hey, you don't have to actually add any new infrastructure. You just need to go map out your facilities, really in a lot of detail and do a lot of sampling and passes. But again, there was accuracy concerns, and it's just not necessarily the best way to get indoor location.
Yeah. So the three items you called out there, the accuracy is one of the biggest cons you had there. The infrastructure costs, we talked about that. So having to install anything or manage anything creates additional work. And then I think the other one that you sort of implied was the actual, I call it breadcrumbing, but it's you need a guy with a map to walk around and at every point on the map, or say where he is and be able to use that to create that initial thumbprint, whether it's magnetic or beacons or anything else, to be able to have that mapped out, right?
Right. And I think most technology, there is some setup process that's going to require that. There needs to be some correlation between, your location and an actual physical GPS coordinate. So if you really want to expand that outside of your facility, there is some setup that's going to be required.
Yeah, that's probably a good transition into leveraging networks for location. I know the advent of this was, I'll call it war driving, but Google driving around for their street maps. They had those big cameras on top of the cars. They were actually, when they were driving, they were also detecting and tracking SSIDs. SSID is it's the signal that your AP emits. So if your AP has a certain, you'll have your MAC address, which is the actual, like the physical numerical hex address for the hardware. And then it'll also have the name of the network sometimes if it's public. But those, Google's tracking those, doing more driving, and it's using that to actually build some fine-grained location early on. So if you had your device and pulled it up and it saw one of those APs, it would know very quickly without even having to use GPS satellites where you were. So it knows I'm within 100 meters of Patrick's house's AP or whatever your AP is, call it your place. So that was the first one. There's also a lot of companies that, or actually not companies, but organizations that did open Wi-Fi maps. I think there were two that I'd looked at previously. The one was the Open Wi-Fi map, and another one was Open B map. But those are both databases you can download, and they had millions and millions of those APs and a geo coordinate, so latitude, longitude, so you actually know where an AP was, which is pretty cool. But I think the latest technology, Patrick, it's been introduced is Wi-Fi RTT or 802.11mc if you like standard and specifications. But can you tell me a bit more about the about 802.11mc, or let's just call it Wi-Fi RTT from now on?
Yeah. So I think of this similar to GPS in a way. I think of it as like a bunch of mini GPS satellites in your store. So access points can now support, what is it, round trip time, RTT. And so they, similar to how GPS works, understanding how long it takes for a signal to go there and back can determine distance. And then, of course, that trilateration principle that we talked about earlier can be applied to determine location. And I think, the sampling is usually, I think, 8 different packets get sent each time it's doing an RTT call. So it's a pretty decent sample size. It's a lot less resource intensive than GPS. And also the accuracy is really within the 1 to 2 meters. So in some ways better than GPS as far as accuracy, which, you sort of need for that indoor locationing. You want as highly accurate possible, so the application can be as contextually aware as possible, knowing down to the aisle, or even maybe what item or department of items that you're in front of. So
when was that introduced? Is that how new is the 802.11mc standard?
So it is pretty new, and Android 9 was when it started being baked into the operating system to support. But if you want your AP to support that, it is slowly being introduced and added that technology. So I think a lot of the major players, of course, have it. For the consumer side, I know the Google Wi-Fi, Google Nest Wi-Fi routers now have that included, but more on the enterprise level, Cisco, Juniper, Aruba, Extreme, they all have some sort of application of this technology to have really good indoor location accuracy.
And those guys also include mapping software, so that breadcrumbing, they make that easy for people, right?
Yeah, so you are going to want a floor plan, PDF, or some type of vector diagram of your site map that's going to get overlaid. But when you set up those APs, you're going to pinpoint the location within the store where those are. And then that's really going to enable all that future locationing without having to do as much of that setup, breadcrumbing, walking each aisle, and doing different readings. It's that technology is kind of leaped beyond that. And so if you have that site map, then you're going to be good to go, especially with these new Wi-Fi 6 routers.
Got it. When you say Wi-Fi 6, can you talk why? I'm assuming that's just anything built in the last 2 years. If it supports Wi-Fi 6, it also has that 802.11mc built in. Is that a true assumption?
I think so. 802.11mc, the protocol, I think was introduced in Wi-Fi 5, if I'm not mistaken, but wider adoption is definitely going to occur with Wi-Fi 6. So those Wi-Fi 6 APs are going to support that super high location accuracy. And kind of as I mentioned earlier, that can be used to, monitor whenever devices come into your network. Even if they're not known, you can understand more or less customer patterns through your store. So pretty cool analytics and operational metrics that are coming off of those APs that I've heard some retailers are starting to look at and analyze.
That's awesome. And then We talked a bit about Android location services before, but how does that leverage this technology? And I feel like maybe you can talk a bit about the kind of the priority it uses to go figure out what it's doing.
Yeah, sure. So I think the first most accurate one is going to be GPS. But when you don't want to have to continuously pull that, so it's going to fall then down onto Wi-Fi locationing. And then cell towers would be a least accurate location compared to those other two. And then finally, if there's no cell enabled, things like the accelerometer, like understanding how many steps you've taken or stairs you've climbed, that sort of data can still help supplement that. So I don't know the exact operations that happen under the covers with Android, but I know that it's really runs down through a list and is going to have some smarts in there to assist you with providing that best possible location, at least as accurate as you need, and do it as efficiently as possible on the system.
Yeah, and location service also tells you its estimated accuracy based on that. So it'll say here's your location, and then here's how far off we think it could be, just based on what methodology or technique it used. So
In
that's
meters,
useful as
I think.
well.
Yeah,
Yeah, no, that's pretty cool. And then we'll definitely, as I mentioned earlier, we're going to be doing a webinar on this, so we'll do some demos of what that looks like when we get to it.
absolutely. Yeah.
So in closing, yeah, I think we're, over the last, I think you said 7 years, you've been tracking a lot of this, but the, Wi-Fi is the front runner for doing indoor locationing, just based on the fact that you can't see satellites, doesn't require that much. It doesn't require necessarily new infrastructure other than access points, which most people already have. Low power, a lot of third-party support. So a lot of the big vendors have great tooling for it. Android has great tooling for it. I guess, are there other considerations that as people start to look at using Wi-Fi and Wi-Fi locations, just any like key takeaways you want people to be thinking about as they start looking at leveraging locationing?
Yeah, sure. There is still going to be a bit of a setup process, as I mentioned, for creating that overlay of a map or that breadcrumbing with your floor plans. And that's really so that you can correlate a location in a store to a location on a map, not just within your four walls, but understanding general location of people. Also, a lot of companies I've seen are doing access point refreshes every 3 to 5 years or so, if not more frequent. I have seen a few other customers, but take a look at those new APs, make sure they're supporting the Wi-Fi 6 standards and the 802.11 MC standards. If this is something that you're looking to roll into your business, going back again to trilateration, that doesn't mean you only need 3 APs. 3 is enough, but the more you have, the more accurate you're going to be. And that's kind of true with just any sensors. The more data you can get, the more accurate your sample is, and the more accurate your conclusion can be around where that location is. And I think the last one is just around the privacy concerns as well. So with 802.11 MC, I think that is required by Android to be device initiated. So with your enterprise devices that you control, they're corporate owned, you control all the permissions on, you can enable that by default. And so your employee associate devices are going to be fine. But the consumer grade devices, there is a good chance a user might have to accept permission or accept providing their location to whatever application or system that you may have. So it is triggered on the device side for that super accurate, contextually aware location, as we've been talking about. But
now the prompt when I set up my Android devices says, do you want to improve your location accuracy? That makes sense now.
Yeah.
Awesome. Well, Patrick, thank you for sharing with us today. And thank everyone who's listening for joining us for another episode of the Enterprise Mobility Roundup podcast. We hope you like the content we shared. If you did, definitely feel free to share the links with your friends or subscribe. And then we love getting ratings and feedback. So feel free to hit like, or on your whatever podcasting software you're using, give us some stars. And then, as I mentioned earlier, look out for upcoming webinar where we do a deep dive into Wi-Fi network location on Android devices. And then Patrick actually will be giving some demos of some of the tools, what that actually looks like from a technology standpoint. But thank you everyone for joining. And Patrick, thank you again.
Thanks, Brett.
Thank you for listening to the Enterprise Mobility Roundup podcast. If you enjoyed the discussion, please take a few moments to rate us. If you would like to listen to future episodes, please subscribe. To learn more about mobility topics or submit any questions, visit us at BlueFletch.com.